Okay. So today it is recording, yes, just to make sure that the recording is on. Today we will start a new chapter, which is chapter 10, the one we left and did radiation, and we'll come back to it now. رح نرجع له اللي هو الفلويدز الموائع. And this will be our lecture today, and we will start with section 1 of this chapter, which is phases of matter. Phases of matter يعني أطوار المادة. حالات المادة. You know that matter can be or can exist in three most common states or phases. يعني هناك ثلاث حالات معروفة بشكل عام للناس, and those are solid. Solid يعني صلب, تمام, أو صلب إذا بدنا نترجمها بمعنى حقيقي وصحيح. طب what are the properties of solids? They have fixed shape and fixed volume. So the shape of a solid is fixed and the volume of a solid is fixed. For example, if you have a ball of iron, the shape is fixed, it does not change. And its volume is also what? Fixed. So those are the properties, the general properties of solids. Now, liquid, does it have a fixed shape, liquids? Water, does it have a fixed shape? Or it takes the shape of the container which you put it in. يعني بتاخذ شكل الإناء اللي بتحطه فيها. Which is correct?
It takes the shape of the container.
Exactly, it takes the shape of the container. Yani when you put water in a cylinder, it takes the shape of a cylinder. When you put water in a sphere, it takes the shape of a sphere. When you put it in a cube, it takes the shape of a cube. So it does not have a fixed shape. It has a variable shape. But its volume is constant, fixed. So liquids have variable shape and fixed volume. Now gas has variable shape and variable volume. Why variable volume? Because you can easily compress a gas. You change its volume, but you cannot change the volume of the water with small forces. You need huge forces to change the volume of water. So we take the volume of water to be fixed, but the volume of a gas is variable. If you have a balloon and you press on it, you change its volume. Why? Because gases can be compressed. Gases can change volume under forces. Okay? الغاز بيغير من شكله, يعني شكل الوعاء يعني if you put it in a cube, it will take the shape of a cube. If you put it in a balloon, it will take the shape of the balloon. And if you squeeze the balloon, the volume changes. So a gas has a variable shape and variable volume. Liquid has variable shape but fixed volume. Solid has both fixed shape and volume. Now, you all know that gases and liquids, يعني الغازات والسوائل, okay, don't maintain their shape, يعني لا يحافظوا على أشكالهم. They take the shape of the container in which you place them, so they don't have fixed shape, and they both can flow. يعني ممكن يتحركوا من مكان إلى آخر, ينسابوا من مكان إلى آخر. If you put water, if you pour water in a table, you will see that the water spreads all over the place. So it flows. Gases also flow. So both gases and liquids are called what? Fluids. Gases and liquids are called what? Fluids. Okay, we call them fluids. And fluids بالعربي يعني موائع. A fluid يعني مائع. Can be a liquid, سائل, can be a gas, غاز. Now, probably some of you have heard about a fourth state of matter. يعني يمكن سمعتوا عن حالة رابعة للمادة. هي مش common to people, مش كل الناس بيعرفوها. It is called the plasma. اللي هي البلازما. بشكل عام plasma occurs at very high temperatures, and it's a mixture of positive ions, أيونات موجبة, and electrons, free electrons. So it's a mixture of positive ions and electrons, and it exists at very high temperatures, like the sun, for example, and the stars. Okay, so those are the main phases of matter. Okay, and the divisions are broad. يعني احنا عمالنا بنحكي بشكل عام. Okay, we will start with some definitions that we will need. بعض التعريفات اللي راح نحتاجها. اللي هي density and specific gravity. Now density, as you all know, is the mass divided by the volume. نسميها كثافة. And therefore we define rho to be equal to the mass divided by volume. If you don't know this symbol, it is called rho. R-H-O. Rho. It's mass divided by volume. And the SI unit of density is the unit of mass, which is kilogram. SI unit of mass, which is kilogram, and the SI unit of volume, which is meters cubed. Okay. Some people sometimes use grams per centimeter cubed. Maybe in chemistry, they tell you that the density of water is 1 gram per centimeters cubed. In physics, we say it's 1,000 grams per meters cubed. This is the SI unit, but this unit is also correct, but it's not the SI unit. So if you take, let me ask you this question. If I give you 10 centimeters cubed of water, I give you a volume of water, which is 10 centimeters cubed. What mass did I give you?
10 grams.
10 grams, Ahsan. Yes, 10 grams. Okay. So each centimeter cubed of water has a mass of 1 gram. Each 1 meter cubed of water has a mass of 1,000 kilograms. And you can easily change from kilogram per meters cubed to 1 gram per centimeters cubed. You just use conversion factors. Very simple. Now, as a very simple example, let us see what is the mass of a solid iron wrecking ball of radius 18 centimeters. Yani, wrecking ball, it's a ball that they use to demolish walls, to break down walls, for example. يعني هو كرة حديدية بيضربوها على حائط عشان يهدموه. They call it wrecking ball. Now this wall is made up of iron, okay, and it has a radius of 18 centimeters. And it's a ball, and it has the shape of a sphere. Okay. Now he's asking, what is the mass of that ball? The radius of that ball is 18 centimeters. Imagine how big it is. It's not that big. It only has a radius of 18 centimeters. What is the mass? We say that mass equals to rho, which is the density, divided by the volume, and density is 7,800 kilograms per meters cubed. I use the SI unit, multiplied by the volume of a sphere. Remember, a sphere, the volume of the sphere is 4/3 pi r cubed. This is r. So volume of a sphere, V is 4/3 pi r cubed, and r is the radius. So the radius is 18 centimeters, and I've changed it into meters so that I can get the mass in kilograms. And that ball with a radius of 18 centimeters has a mass of what? 190 kilograms. This is a lot larger than water. See, density of iron is 7.8 times larger than the density of water. Density of water is only 1,000 kilograms per meters cubed, while iron is 7,800 kilograms per meters cubed. So it's 7.8 times larger. Now, specific gravity is defined as following. It is the density of the material, divided by what? Density of water, density of the material divided by density of water at 4 degrees. Why 4 degrees? Because when we say that water has a density of 1,000 kilograms per meters cubed, this density occurs at 4 degrees. At lower temperature, the density of water is lower than 1,000. And at higher than 40 degrees Celsius, it is also lower than 1,000. So water has a density of 1,000 kilograms per meters cubed when the temperature is 4 degrees Celsius. So when you define specific gravity, you divide the density of the material divided by the density of water at 4 degrees. For example, for iron, what is the specific density for iron? Who tells me? For iron.
7.8.
Yes, Ahsan. Specific gravity equals to specific gravity equals to 7,800 divided by 1000 and it equals to 7.8. Note it has no dimensions because it's density divided by density. So if I give you the specific gravity of any material, you can very simply calculate its density by multiplying it by 1000. Okay. Now we define pressure of a fluid. ضغط الماء. Pressure is defined as the magnitude of the force per unit area where the force is perpendicular to the area. Okay, so pressure is force per unit area. If you have a force that is acting on an area, on a given area, if you divide the component of the force that is perpendicular to that area, divided by the magnitude of the area, you get what we call what? The pressure. Okay, so pressure is basically force divided by area, but that force has to be what? Perpendicular to the area. So if this is the area, okay, and this is the force F, and it makes an angle theta with the area. If I define pressure, I say it is F sine theta divided by A. Okay, why? Because I need to take what? The vertical component. This is area A. So if I want to define the pressure here, I say that P equals to F sine theta. Why did I take sine theta? Because I need the vertical component. The vertical component is this. This is F sine theta, and this is F cosine theta. Which one is perpendicular to the area? Is it F sine theta or F cosine theta?
F sine theta.
F sine theta. So it's F sine theta divided by what? Divided by A. I must always take what? The perpendicular component to the area. And it has units, pressure now has units of newtons because it's a unit of force, divided by area, which has a unit of meter squared. Now, 1 Newton per meter squared is called what? Pascal. So Pascal is the unit of what? Pressure. Pascal is the unit of pressure. Is it a basic unit or a derived unit?
Derived.
It's a derived unit. It's not a basic unit because it's made of Newton divided by meter squared. So it's not a basic unit. Newton is also not a basic unit. Okay. So the units of, or the unit of pressure is the Pascal, and 1 Pascal is a force of 1 Newton acting on an area of 1 meter squared, such that that force is perpendicular to that area. And that's what we mean by pressure. And note, pressure is a scalar quantity. It's not a vector quantity. Pressure is a scalar. It only has magnitude. We do not associate direction with pressure. Let's see an example. Calculating pressure. We want to calculate the pressure of what? We have a 60 kilogram person's 2 feet cover an area of 500 centimeters squared. Yani the 2 feet of a person whose mass is 60 kilograms have an area of 500 centimeters squared. يعني أسفل القدمين الملامسات للأرض. Okay, the part of the foot that is in contact with the ground has an area of 500 centimeters squared for both feet. The sum of the areas of both feet which are in contact with the ground has 5 centimeters squared. Determine the pressure exerted by the 2 feet on the ground. يعني هو بده الضغط الناجم عن القدمين هذول لما يقف هذا الشخص على الأرض okay, بده ضغطه على الأرض. So what we say, let me say pressure P equals to the force divided by the area. Now where does the force acting on the ground come from? من وين جاي هذا القوة اللي مأثرة على الأرض؟ Weight, yes, the weight of the person. اللي هو وزنه. فإتس mg, the weight of the person, divided by A. What is the area in this case? He is standing on both feet. He is standing on both feet. So the force is the weight of that person divided by the total area of his feet. Okay, So his weight is 60 multiplied by 9.8, and the area is 500 divided by 10 to the minus 4. Where did this 10 to the minus 4 come from?
حولناها لمتر سكويرد.
ايه
لما حولناها لمتر سكويرد.
ايوه حولنا from centimeter square to meter squared. To get pressure in pascals, you need the force to be in Newton and the area to be in meter squared. And you get 12,000 pascals. Yani when that 60 kilogram person stands on the ground, on both feet, where his feet have an area of 500 centimeters squared, the pressure that he exerts on the ground is 12,000 pascals. Okay. لما يكون واقف شخص كتلته 60 كيلوغرام على قدميه ومجموع مساحة القدمين الملامسات الأرض 500 سنتيمتر مربع، ضغطه على الأرض شو بيساوي؟ 12,000 باسكال. This gives you a feeling of how much a Pascal is. It's 1 Newton per meter squared. طيب, what happens if he raises 1 foot and keeps only the other foot in contact with the ground? يعني بيرفع قدم وبيخلي القدم الثاني ملامس للأرض. What do you think changes here?
بتضاعف البريشر؟
Exactly. The pressure is doubled. Why?
لأنه نفس القوة على مساحة أقل.
It's the same force which comes from the weight divided by half the area. Why half the area? Because he lifted one of his feet off the ground. لأنه رفع واحدة من قدميه. إذا نص الاريا الأصلية هي اللي ملامسة للأرض اللي هي قدم واحدة. فbecomes A over 2. مظبوط. 2 is the denominator of the denominator, so it becomes a numerator, and you get 2 mg over A. طب ما هي mg over A 12,000 multiplied by 2, so the pressure becomes 24,000 pascals. So by lifting 1 foot off the air, okay, the pressure on the ground is what? Is 24,000 pascals, 24,000 newtons per meter squared. This means that the force of 1 foot on the ground is larger than, but let me not go into this. But when you stand on 1 foot, all your weight, let me put it this way, when you stand on 1 foot, all your weight is supported by 1 foot only. So you place all your weight on 1 foot. يعني لما تقف على قدم واحدة انت عمالك بتحمل كل وزنك على قدم واحدة. Is this good or bad? This is bad. You need to distribute your weight on both feet. يعني وزع وزنك على القدمين. كل قدم بتشيل نص الحمل. If you put all your weight on 1 foot for a long time, that's not good for you. It's not good for your joints حتى. Always try to stand on both feet. Do not put more weight on 1 foot than the other. Okay? Now, we will start with static fluids. Oh, static, you know what it means. What does static mean?
ما بتغيرش يعني حجمه.
يعني at rest basically. لا يعني هو إنه الفلويد at rest. That's what it means. Because you can have running water. This is moving fluid. And you can have still water in a glass of water. You have the water being still. It's not moving. That's what we call static fluids, which are fluids at rest. Okay, they are fluids at rest. So this is a beaker, container that has fluid. Could be water, could be oil, whatever. It's a fluid. Now there are properties of fluids at rest. The first property is that, look at this, if we take a very small volume of that fluid, assume it to be a cube, you have pressure acting on the fluid in all directions, from all directions that pressure. And the magnitude of that pressure is the same. Okay, the magnitude of the pressure is the same. So that's one property of fluids which are static. You know, the pressure at a point inside the fluid is in all directions, and equal in magnitude. يعني يؤثر في جميع الاتجاهات ومقداره شو ماله كمقدار ثابت. Okay, that's the pressure on this little ball or little cube of the fluid. Okay, طيب, what is the evidence that the pressures acting from different directions are the same? Now let's suppose the following. If this pressure or let me, ما هو pressure and force, you just divide the force by the area, you get the pressure. So let me talk about forces here, because I have arrows and arrows are associated with forces. The force from right to left on this ball must be equal to the force from left to right on this ball. طب مين بيعطيني evidence this must be true? Why should this be true? Why should this force be equal to this force? And therefore, if you divide the force by the area, you get the pressure. So the pressure from this side equals to the pressure from this side. What is the evidence that this is correct?
إنه static.
لأنها ثبتت.
Exactly. This ball is static. It's not moving. تعرفوا لو this force is greater than this force, it will move to the left. If this force is greater than this force, it will move to the right. So since it's not moving right or left, it means that this force is equal to that force. So the force divided by the area is the same as the force divided by the area. So the pressures are the same. So for static fluids, the pressure at a given point acts in all directions, and its magnitude at that point is the same. That's one property. The other property is the following. Now, this is a beaker or a container. Forget this for now. Forget this. This is a container. Where do you think the pressure of the liquid on this wall acts? In which direction? I have a liquid here, and I have this wall, and that liquid is in contact with this wall. In which direction is the pressure of the liquid acting on this wall? Do you think it will act with the pressure to the left, to the right, up with an angle, or down with an angle?
To the right.
To the left.
The liquid on the left wall, the liquid on this left wall should act where? To the left. To the left. It does not pull the ball, it pushes the wall. So it acts to the left. Here, it acts to the right. طيب, does it act with an angle or perpendicular to it? Now suppose, let's just for the sake of argument, فقط خلينا نفترض حتى نعرف نتناقش إنه the force of the liquid acts on this wall along this direction. Suppose, and I put two lines under suppose. افترض. Now this means that this force has two components. One is perpendicular to the wall, and the other is what? Along the wall. Yani, in other words, the liquid will be acting with a force on the wall of the container to the right, and will be acting with a force on the wall of the container upwards. اللي هي component سمانها parallel component because it's parallel to the wall, and perpendicular component because it's perpendicular to the wall. طيب, if the liquid acts on the container with a force upwards, we can call this an action. There should be a reaction according to Newton's third law, which says that the wall must act on the liquid with the force where? Downwards. So if the wall acts on the liquid with a force downwards, it means that it's going to move that liquid. But the liquid is not moving. This means that you can never have a component of that force parallel to the wall. So the force must be what? Must be perpendicular to the wall. If you did not quite get this, think about it at home, or just know that the pressure of a liquid that is static inside a container, that pressure is perpendicular to the wall, which means that the force of the liquid on the wall is perpendicular to the wall. In fact, for any static fluid, any fluid which is at rest inside a container, the force due to that liquid on any wall that is in contact with it is perpendicular to that surface. يعني السائل الساكن يؤثر بقوة على أي سطح تلامسه بشكل عمودي عليه. ما هي هاي النورمال فورس اللي تعودنا عليها. ما هو the liquid is in contact with the wall معناته في بينهم normal force. وحكينا النورمال فورس هي عمودية على مين؟ The normal force is perpendicular to the surface of contact. معناته هي عمودية على هذا السيرفيس. إذا two properties that you should know. That for a static fluid طبعا. The pressure at any point inside the fluid acts in all directions. And at that point, the magnitudes of the pressures are the same, which is the first graph I put, not graph picture. And the second thing is that the liquid which is static inside any container, that liquid would act with a pressure that is perpendicular to the what? To the wall. It acts with a pressure that's perpendicular to the wall or surface of contact. It's basically a normal force. So this parallel component always equals to what? To zero, provided the liquid is what? Is at rest. هنا for a static fluid. يعني للمائع شو ماله؟ الساكن. Okay. Since we know that liquids have pressure, let us try and calculate the pressure due to a liquid at a given depth below the surface of the liquid. So you see, you have a container which has more or less a cubical shape. This is a container, and that container has liquid up to this level. Okay. Now what we are trying to do is to calculate the pressure at this area here, okay, which is at a depth h below the surface of the liquid. So this is what the question is asking for. We need the pressure of the liquid. لاحظوا I am only calculating the pressure of the liquid. Why am I saying this? Because there is also a pressure due to the atmospheric pressure if this is open to the atmosphere. I am only interested in what? In the pressure of the liquid. Later on we will say something about how to add the atmospheric pressure. Now the pressure of the liquid on the area A is due to the weight of the liquid. Why? Where does the pressure come from on this area? It comes because you have liquid on top of this area. Okay, that liquid has mass, and if the liquid has mass, it means it has weight. Weight is a force. If you divide by that force by the area A, you get what? You get the pressure. So pressure equals to force per unit area, F divided by A, is going to be mg, which is the weight of the liquid on top of this area, divided by the area. Now remember, we said that the mass equals to the density multiplied by the volume. And why do I have rho F here? It's the density of the fluid. High density of the fluid, rho F high. Density of the fluid. So you have rho fluid Vg divided by area. It's going to be equal to, who tells me what is the volume of this box of liquid? The box has an area A and height h. What is the volume of this liquid?
A squared by h.
A multiplied by h. Yes, it's the surface area of the base, okay, divided by what? Divided by h. It's the area divided by the height. So instead of volume, I can write A multiplied by h multiplied by g divided by A. This is the original A. What happens to the area? It cancels out. So you get P equals rho fluid, density of the fluid, multiplied by the gravitational acceleration multiplied by h. Now, if I ask you, as I go further down in the liquid, as I move down, does the pressure increase or decrease? The pressure of the liquid.
Increase.
Decrease.
Yes, it increases. You see, pressure is proportional to the height. or not, let me not say the height, to the depth below the surface of the fluid. Okay, so the pressure increases with depth. So the deeper you are under the surface of the liquid, the more pressure you have on you. So when divers go underwater, they really must know exactly to what depths they are allowed to go. If they go very deep down, they might crush themselves. They might die because they have so much pressure on them due to what? Due to the column of water on top of them. So divers always calculate exactly to what depths they can go, and depending on the pressure they want to, they will be affected with, or the pressure that is acting on them, they wear special suits, and they have cylinders of oxygen to breathe. Okay, so divers have a very difficult task to do sometimes. I want to tell you about something. It's called, you know, something called the snorkel. Snorkel is a pipe. Some people try to dive, they don't have a diving suit and they don't have gas cylinders with them. They want to go to 1 or 2 meters below the surface of the water. They have something called a snorkel. Snorkel يعني زي بربيش, زي أنبوب. He has the one end in his mouth and the other end above the water surface. يعني واحدة جهة من البربيش أو الأنبوب بتكون في فم الشخص, والجهة الثانية بتكون وين؟ برا في الهواء. Why does he use it? He uses it to breathe. He's underwater. Now, if he goes deep down, he will die probably because he will get his lungs crushed. And the reason is very simple. Why? Because the pressure on his body is due to what? Due to the water pressure, the column of water on top of him. If that column of water is large, معناته he has very high pressure. While the pressure inside his lungs is equal to what? الضغط جوا رئتينه شو بساوي؟ ما هو مشبوك مع الضغط الجوي. من خلال مين؟ من خلال الأنبوب. الضغط داخل رئتينه بيساوي الضغط الجوي، بينما الضغط خارج جسمه واللي بالتالي بيأثر على رئتينه وبيكبس عليهم, it compresses them, هو الضغط الناتج عن السائل. Now if the difference between the water pressure on his body and the atmospheric pressure is large, he will not be able to breathe. But this means he has to go down deep in the water. Okay, I hope this made sense to you. Okay, note one thing, another important thing. In addition to the pressure being proportional to the depth below the water surface or the liquid surface, it does not depend on the area. شايفين? Do you see any area here? You see no area. So the pressure is only proportional to what? The height, considering that the fluid density is constant and G is constant, it's proportional to the depth. When I say height, I really mean the depth below the water surface. Okay. Okay, let's check now if we really understand what we've done. There is a big difference between what students think they understand and what they really understand. Look at those shapes, A, B, C, D, and A, B, C, and D. Tell me in which container is the pressure highest at the bottom? A, B, C, or D?
D.
شايفين
D.
إجابة D. Does anyone have any other answer? In which container is the pressure highest at the bottom of the container? I tell you something, each one of you must answer this question correctly, provided two things are satisfied. كل واحد فيكم لازم يجاوب هذا الجواب. إذا هو فعلا موجود الآن وبي watching the lecture, مش بس فاتح عليها ونايم أو رايح على مكان ثاني. And if you really understood what we did before. Yes, what's your question?
جواب دي عشانها انه جيت ديف عشان الايكويجن رو جي اتش.
أيوة أحسنت. نعم.
اتش هي اللايف
Yes. The answer is D. Why? Because this is the largest depth below the water surface. Yani in other words, the water column here is high. So you have a lot of water, that's a lot of mass, that's a lot of weight, okay? And some people say This is a large area, so the pressure, for example, it's not the area. We know that the pressure is independent of the area. Why is the pressure here small? Is it because the area is large?
No, H is small.
H is small, yes. Pressure has nothing to do with the area of the container because pressure is force per unit area. You've divided by that area. Okay, so what I care about is the depth of the water, and this has the largest depth. In other words, this has the largest or highest water column. So the pressure here is what? Is maximum. Which container has the lowest pressure?
A.
A, yes, because it has the lowest depth. Which is the one next to it after that? Which is one next
C.
closest? C. And then what? B.
B.
And then what? D.
D.
Okay, that's so A, D has the highest pressure, then B, then C, then A. Okay. Why? We only care about the height of the liquid. That's what we care about. Okay. So the answer is D since H is largest. Now let us look at this. I want to compare the pressures at two different points. And this is a liquid. This is the surface of the liquid. We have an object here. At this instant, tell me, where is the pressure higher? At the top surface of the liquid or at the bottom surface of the liquid? Where is the pressure higher؟ وين الضغط أعلى؟ على الوجه العلوي ولا على الوجه السفلي؟ على الوجه السفلي. نعم. Why? The question is why. Whenever you answer something, ask yourself why. If you can answer it, then most probably you are correct. طب ليش البريشر هنا أعلى؟
H is larger.
H2 is higher. This point here is at a larger depth below the surface water, the water of the surface of the water than this point here. Okay, so the pressure here is greater than the pressure here. Now let me go, before going a little bit further, if I want to calculate P1, I say that P1 equals to raw fluid times G times H1, and this is H1, and it acts downwards. Now pressure is force per unit area. This means I have a force where? Downwards. Type for this, the force, where is it going to be? Upwards. So what is pressure if P2? Pressure P2 equals to raw fluid G times H2. Okay, and I know that P2 is greater than P1 because H2 is greater than H1. So what is the difference in pressure? Since the pressure at the bottom is larger than the pressure at the top, I have a pressure difference. Okay, and delta P equals to P2 minus P1, and it's going to be equal to raw fluid G, which is a common factor in both, multiplied by H2 minus H1, and H2 is greater than H1. So pressure P2 is greater than pressure P1. So what is the pressure difference? The pressure difference is raw fluid times G times delta H. Delta H is the difference in height between those two. Now if I call this, he called it delta H, you can call it H if you like, H2 minus H1. So delta P equals to raw fluid G times delta H. Now since the pressure here is greater than the pressure here, and those two areas are the same, which is larger, the force that acts on the bottom surface or the force that acts on the top surface?
The bottom surface.
Bottom surface. Well, look at this. The arrow is longer than this arrow. So what is the resultant force of those two forces? Is it up or down?
Upward.
Up. Always, whenever objects are in fluids, okay, whenever they are in fluids, there is a pushing force where? Upwards on those objects. Now when you are in water, you feel something is pushing you upwards, مظبوط? Why? Because the lower parts of your body are at a higher pressure than the upper parts of your body. Higher pressure معناته higher force, معناته you have a force upwards from the liquid greater than the force downwards, and this gives a net force where upwards due to the liquid, which this makes you move up. But what other force is opposing this? في قوة ثالثة. There's another force acting. Which is it? Or what is that force?
Weight?
Weight, yes.
What?
You have the weight. So you have the weight of your body acting down, and you have a force from the liquid acting where? Up. Now, are you going to move up or down? This depends on the net force from the liquid, which is called, we will do it later, it's called the buoyant force, and your weight. Now, for this object, if its weight is larger than the net force of those two forces, it will move down. If its weight is, let me repeat this statement. Now, let me say that Fr, resultant force, just to quantify things, Fr equals to F2 minus F1. Now, if the weight of the object is greater than Fr, tell me first, where is the direction of Fr? Is it upwards or downwards?
Upward.
Upwards, yes, this is upwards. Upwards, hey, this force is upwards. طب مين بيحكي لي ليش upwards? Since
لأنه F2.
it was greater than F1, exactly. So it's upwards. But what is the other? And if you see this object here, you have two forces acting on it. The first force is Fr. We will see later, this is called the buoyant force, called, I might as well write it down, called buoyant force. Buoyant force يعني قوة الطفو, and you have mg downwards. طيب, if R is greater than mg, what happens to this object? لو كانت Fr أكبر من mg, what happens? أيوة,
Go up.
object floats. Object floats. شو يعني floats؟ يطفو.
يطفو.
نعم، يطفو، نعم. طيب وإذا كانت Fr أقل من mg, what happens?
رح تنزل تحت الماء.
Object sinks. بالضبط. Okay, we will be doing this later. This force from the liquid on an object, when that object is inside the liquid, is called the buoyant force. Buoyant force يعني قوة شو هي؟ يعني قوة الطفو. Whenever, which is, when you go inside the water, do you feel that your weight has increased or decreased?
Decreased.
No answer. أكيد decreased.
Decrease.
Just give me any one person, he felt that he is heavier in water than in air, and I will give him a prize. This never happens. Always, when you go inside water, you feel that your weight has decreased. Why? Because you have a pushing force where upwards. When you come out of the swimming pool, لما تطلع من بركة سباحة, as you come out, at the moment you come out of the water, you feel that you need a large force to move your object. While when you were in the water, you only need a small force and you will move your object, your body. Why? Because you have a force pushing you upwards. Once you leave the liquid, once you are out of the pool, that force no longer exists from the liquid. So you feel that you are heavy. Try it just as you come out of the swimming pool if you go swimming. Okay. Let's do another example. We have, this is a water tank, and this is our house, and you have a tap here. They call it a faucet. Tap. And the water, you all know that the water will go down and into the tap, tamam, and into the house. What is he asking for? It calculates the difference in pressure between the level of the water here, the level of the tap here, and the level of the top of the water here. That's very simple. That height is 30 meters. Okay. Now, delta P, which is the difference in the pressure between this point and this point, equals to raw fluid times G times delta H. What is delta H? It's the difference in height. So how do I calculate delta H? I say it is this height. Let me call it H2. Minus this height, which is 0. H1 is 0 basically. Why? because the water surface here is at this level. I measure my height from the surface, okay? So this faucet here, or this tap, is 30 meters below the water surface, and it is H2. And here it's at this level, so H1 is 0. So delta P equals to raw fluid G times delta H. Raw fluid is 1000, G 9.8, and delta H, H2 minus H1. Hey, H2 minus H1, what does it equal to? 30. So the pressure difference is 2.9 times 10 to the 5 pascals. Okay, so the pressure at this point, أكيد is higher than the pressure at this point. Because as we go deeper, وهذا صار عندي water column. As I go deeper, what happens to the pressure? It increases.
Increases.
Because I have a larger water column. So the pressure increases as I go where? As I go down. Okay. Any questions? But before I finish, let me just tell you something. All what we have calculated so far is the pressure due to what? هنا حسبنا البريشر الناتج عن مين؟
عن المي.
بس عن الليكويد بالضبط. Only due to the liquid. If some of you might think the following: can I calculate the pressure at this point taking into account the atmospheric pressure? يعني انتم بتعرفوا انه the air has also pressure which acts where? At the surface. مظبوط. So what is the pressure at P1 due to the liquid and due to the atmospheric pressure? We can ask that. Let me say the following. Let me first calculate the pressures due to the liquid. Okay. Yes. Delta P between this point and this point equals to P2, which is the pressure at this point, minus P1, which is the pressure at this point, which is going to be equal to rho times G. طبعا raw fluid هاي. Okay. Raw fluid. But I have not added raw fluid all over the place. That's raw fluid. And this is raw fluid. Why do I have F? Because next lecture we will be having the density of the object, which is I will call rho 0, for example, or rho O. So P2 minus P1 is going to be equal to raw fluid G times delta H. What is delta H? Delta H is H2 minus H1. That's right, H2 minus H1. So we measure our distances from where? From the top of the liquid. So which is larger, P2 or P1? I keep P2. Why? It's at a higher depth below the surface of the water. What is the difference between the two pressures? It's P2 equals to P1 plus raw fluid GH. يعني P2 minus P1 equals to raw fluid G time. يعني the density of the fluid multiplied by G multiplied by the height difference between them. That's the difference in pressure. So what is the pressure of P2 itself due to the liquid? Due to the liquid. Okay, I say that P2 must be equal to P1 plus rho fluid G times delta H. Yani the pressure of this point equals to the pressure of this point. What do I add to it? The pressure due to this column of the liquid. So far, I am only calculating the pressure due to the liquid. But if some tells you that this container is open to the atmosphere, so I have a pressure here, I say yes. Now I can say, what is the total pressure at P1? What is the total pressure at P1? Definitely you will tell me it is the pressure due to the liquid here. Now the pressure due to what? To liquid, which we have been calculating so far, plus what? Plus the atmospheric pressure. هذا atmospheric pressure. That's the total pressure at this point. So what were we calculating before? When I wrote P1, what did I mean? I meant the pressure due to the liquid only. But I have another pressure due to the atmosphere. So I say P1 total, that's the total pressure, which is I have written here, it's the pressure due to the liquid and the air, atmospheric pressure, equals to the pressure due to the liquid plus the pressure due to the atmospheric pressure. As simple as that. Also P2 total will be equal to P2 due to the liquid plus PATM due to the atmospheric pressure. So calculate the difference between them. Note that the atmospheric pressure has the same magnitude at both points. مظبوط. atmospheric pressure هون هو نفس atmospheric pressure هون. This is a consequence of something called Pascal's principle. We will come to it later. But the atmospheric pressure acts at this point and at this point by the same amount because we are inside the liquid, and it acts at all those points. So what is the pressure difference between them? Total pressure difference, P2 total minus P1 total. Evaluate. P2 total is P2 total plus ATM minus P1 total is P1 plus ATM. What happens to ATM? Cancels out. So we are back to P2 minus P1. Why did the difference, or why did the atmospheric pressure not affect the difference between the pressures of the 2 points? ليش الضغط الجوي ما فرق في فرق الضغط ما بين النقطتين هذول؟ لأنه إحنا داخل السائل. Exactly, نفس atmospheric pressure here is the same as the atmospheric pressure here. So when you subtract the pressures, you just cancel the atmospheric pressure. Okay? So when you are inside the liquid, when you have a liquid, and at different points of the liquid, okay, at different points of the liquid, the atmospheric pressure acts by the same amount at this point and this point and this point and this point. So when you calculate the difference, what happens to the atmospheric pressure? It cancels. So this is the difference, whether you calculate the difference between those two due to the liquid, or if you take the atmospheric pressure. In both cases, the pressure difference is rho g times delta H. Okay. Any questions? Next time we will see that we will continue and see what is the pressure, or what is the relation between the pressures of all points at the same depth below the surface of the water. We will do that next lecture. Do you have any questions before we break?
يعطيك العافية دكتور.
الله. إذن we will see you يوم الأحد إن شاء الله.
بس في سؤال صغير.
على المادة.
العافية دكتور.
على المادة.
على المادة أوكي.
هسه لما يكون مثلا في جسم جوا المي، حكينا السطح العلوي بيكون ضغطه أقل من السطح السفلي بناء على الارتفاع.
لا مش هيك، نحكي الضغط على السطح العلوي، يعني the pressure on the upper surface is lower than the pressure on the lower surface. Yes, that's true.
بس هسه احنا ليش ما هسه هم فعليا ضغط السائل، كمية السائل نفسها فوقهم، يعني نفس الاشي، كمية السائل فوق السطح العلوي نفس كمية السائل فوق السطح السفلي، بس الفرق في وزن الجسم نفسه، يعني وزن الجسم بأثر على الضغط.
No. لا. It's good that you raise this point. And I think what you are saying is انت اللي بتحكيه انه كمية السائل هاي اللي هون اوكي هي نفس كمية السائل اللي فوق هذا اللي بتحكيه انت، ولذلك البريشر لازم
تمام عشان ما فيش مي بالنص يعني.
Okay, fine. I'm glad you asked this. This is a good question. Now look at this. The pressure at this point here, you see this formula P at any point شو بتساوي؟ rho times G times what? Times H. مظبوط ولا لا؟ Now if you take this point, it is at a height H2 below the surface of the water. مظبوط ولا لا؟ طب if you take this point, also it's at the same height. معناته the pressure at this point is the same as the pressure where? At this point. Those 2 points have the same pressure. طيب you can ask me how do I make sure of this? أنا بحكي لك هذا السائل is a static fluid. تعرف لو كان البريشر هون، يعني according to what you said، بناء على اللي انت حكيته، انا مبسوط انك سالت هذا السؤال. لو كان البريشر هون اقل من البريشر هون شو راح يصير؟ What happens?
يصير في حركه في السائل.
Exactly. Fluid will move from the higher pressure to where? To the lower pressure. صح؟ إذن even though you think that the amount of fluid here is less than the amount of fluid here, which is you are entitled to think so, the pressure at this point must be equal to the pressure at this point. The liquid will move and rearrange itself until the pressures at those 2 points are what? Are the same. Tamam? Are the same. What is the evidence for this? The evidence is that the fluid is in static equilibrium. It's a static fluid. لو كان في فرق في الضغط ما بين هذول الثنتين, water will flow from this point which you think is at a higher pressure to this point which you think at a lower pressure. هسا let me give you a more clear example. When you are inside your house now, صح? You have the ceiling of your house. طيب, can you say that the pressure inside the room, the atmospheric pressure inside the room is less than the atmospheric pressure on the top of the ceiling outside, يعني on the ceiling of the house? تقدر تحكي هالحكي؟ تقدر تحكي انه الضغط الجوي داخل الغرفة أقل من الضغط الجوي فوق على السطح؟
لا.
طبعا لا. They are the same. طب لو كانوا مختلفات what do you think will happen؟ لو كان الضغط الجوي جوا غرفتك أقل من الضغط الجوي على السطح شو بصير؟ air will flow from the ceiling من فوق سطح البيت بدخل من الشباك وين بروح؟ بروح على غرفتك صح ولا لا؟ In a summer day do you feel any air movement, strong currents of air موجود؟ مش موجود. طب شو السبب؟ لأنه the pressure inside the room is the same as the pressure where? On top of the ceiling. في أي لحظة بيحصل فيها فرق في الضغط ما بين نقطتين الهواء مباشرة بيتحرك من الضغط الأعلى لوين؟ إلى الضغط الأقل. والliquid also moves from the higher pressure to the lower pressure. فthe liquid will rearrange itself until the pressure at the same height in the liquid is what is the same. واضحة هاي؟
بس هو في نقطة دكتور إنه هسا أنا لما أحط جسم في المي هو أولها بيكون في حركة وفي ضغط بعدين بثبت السائل.
That's what I'm saying. مش حكيت لك the liquid will rearrange itself؟ مش أول ما تحط الليكويد بيتحرك؟ بعدين شو بصير فيه؟
تمام، يعني أولها بيكون في فرق بالضغط نتيجة الوزن.
مش نتيجة الوزن، لأنك أنت حطيت جسم داخله، تمام؟ وعملت displacement of the liquid. When you displace the liquid you moved it. It's no longer static. مظبوط ولا لا؟ حركته، مش ساكن هو. بيضل يتحرك في الأخير بيسكن. متى بيسكن؟ لما الضغوط عند نفس الارتفاعات شو تكون؟ متساوية. Exactly what you said is correct. Initially it moves. بيتحرك ليش؟ لأن أنت you disturb the system. لما دخلت هذا when you move this object inside the water أنت شو عملت؟ مش هذا الأوبجكت زاح كمية من المية. The water will start moving. And this movement continues until when? Until the pressures at the same height are what? Are the same. When they are the same, now we say it's a static fluid. تمام؟
تمام وصلت دكتور، شكرا.
Excellent. That's a good question. I'm glad you asked this question. Any other questions? Okay. So inshallah we'll see you on Sunday. نشوفكم يوم الأحد.
يعطيك العافية دكتور.
Stop recording.